mean, I could do that, but people were telling me it's super loud, so I was going to do that. All right. Oh, this is not working. All right. So today someone's going to the hospital. L'hôpital. Nope, I'm moving this back. There it is. Limits at infinity. So today we're learning to evaluate limits using cool techniques. Oh man, it's so cool. Oh my gosh, I love 10 days technique. Speaking of, we'll be successful when we can set limits to L'Hôpital. Oh my God, it's such a cool lesson. All right, here's a limit at infinity. And at infinity because x is going to infinity. The question is, what's the value of that limit? Does it have a value? It does. And the value is 3. The value of this limit is 3. So I want you to think in your heads just for 15 seconds. How could you do that? Graphically? Algebraically? You did it algebraically. Giant ones, dominant terms, calculus. I mean, I just gave it to you, but how would you go through, verify that that's 3? Boom. Okay. So there's a lot of different ways you could approach this and hit this up. And any of these are totally fine. But I really want to emphasize the calculus part. So basically, however you evaluate this is using calculus because a limit is calculus. So no matter what you did, you use calculus. Yay! There is a technique that none of you used, but I did, that involves derivatives. And it's quick, it's clean, and it's effective. Well, you wouldn't be interested in learning about that, would you? And maybe you're not, but we're going to do it anyways. It's called L'Hôpital's rule. Some people call it the hospital's rule, but I really hate that because I have a minor in French, and L'Hôpital is clearly French. And to call it the hospital's rule is like a major freaking slap to the face, and it just sounds like cringy to the highest degree. And so I just will not do that. There's a lot of things I'm willing to talk about and compromise. That is not one thing. I will not agree to disagree. I will set siege to whatever place you're at and fight you about it because it's important. I'm going to call it L'Hôpital's rule. Technically, there should be a circumflex over the O, but it was a pain in the butt, so I just left it off. So we're going to look at this statement of L'Hôpital's rule. This statement looks a lot more complex because it necessarily needs to be than what you're actually doing. So we're going to take a look at it, see what's up, and then we'll point out like what it means and point out some other characteristics. So if you have a limit that's going to infinity or towards a value of some fractional limit of some fractional expression, and that limit is indeterminate, and the derivative of both the numerator and denominator exist, then that infinite limit is equal to the infinite limit of the derivative divided by the derivative, or the limit at that value of the derivative over the derivative. This is what L'Hôpital's rule allows us to do. It allows us to take the derivative of just the numerator, just the denominator, and try the limit again and see if it works. And if it works, that's the limit of that's the value of the original limit and the derivative. By the way, we can reapply L'Hôpital's rule as many times as we want, as long as the result is indeterminate. Speaking of indeterminate, just to make sure you remember what indeterminate means, because we talked about that quite a bit in pre-calc. Indeterminate is when you have 0 divided by 0 or infinity over infinity. Because neither one of those necessarily simplify to 1, but they look like they should, but they don't. Okay? So that's what indeterminate means. By the way, these two bottom things, they are particularly useful for a lot of different things. Just knowing that 1 over x as x approaches infinity is 0. Nothing else. It is 0. And the limit of x over 1 as x approaches infinity is infinity. So let's see how L'Hopital's rule looks in action. Because again, you look back at this statement, you're like, "Oof, that's a thing. Oh my, that's a thing." So let's look and see what this looks like in practice on the one we just did. So I'm told you the limit of this one was 3. Well, if I plug it in infinity, it's a constant, not a number, but if I plugged it in, I would get infinity over infinity. So that's indeterminate. I can use L'Hopital's rule. Yeah, L'Hopital's rule. And I get 6x over 2x. If I plug in infinity again, I still get infinity over infinity. That's indeterminate. L'Hopital's rule. Well, let's take the derivative of each of those again. 6 over 2. Hey, as x goes to infinity, it's just 3. L'Hopital's rule is pretty friggin' slick. I think it's super slick. Now, most AP questions that deal with something like this are usually non-calculator questions. So which it basically means you have about 3 different ways that you can deal with something like this. Now, I don't really know exactly how that all work out with the AP test, whether it'll be in person or virtual. My bet is it'll be virtual, which kind of sucks, but that's probably what needs to happen. But who knows? By then, maybe most of us will have a vaccine. So who knows? We have 2 effective vaccine candidates out there. So who knows? We'll see. But anyways, here are the techniques that are your best bets. Algebra infinity, dominant terms, and L'Hopital's rule. So I'm going to show you how to do the same problem with all 3 of these. So algebra infinity is you basically just divide each term by the highest degree polynomial. So the highest degree polynomial in here was x to the 3rd. So I divided each term by x to the 3rd, and I get this. Bam. And then if you let infinity happen, you just get 2 over 1, which is 2. Sick. Dominant terms, we're just going to isolate what the dominant terms are, which are these 2. And then simplify that as much as we can. Those simplify away, we just get 2. Sick. L'Hopital's rule for this one takes a couple more steps, but it still works. So we do the derivative once to get here. Again, plug it in infinity, you still get indeterminate. Plug it in, do L'Hopital's rule to get down to this to 12x minus 2 over 6x. You still get indeterminate when you plug in infinity. Do the derivative one more time, boom, you get 12 over 6, which is 2. So no matter which one you do, you still get there. Now, some of these require more work or less work than others, but the cool thing about L'Hopital's rule is that you can work it at infinity or just some value like 7 or square root of 6 over 3. Fun fact. Whoa. I did a lot of laughing on the next slide. Algebra infinity and dominant terms, those techniques only work as x approaches infinity or negative infinity. L'Hopital's rule can work at infinity again or at a constant, some value. So just remember that. That's an important thing you need to remember, because if you try to do that at another value, things are going to blow up and it's going to be terribly wrong. All right. So speaking of AP questions, I know you all love the questions that look like this. These are definition of the derivative questions. And these are assessing whether or not you know what the definition, if you know the definition of the derivative. Maybe you do, maybe you don't. But if you know L'Hopital's rule, you don't really need to know that. You just need to know your derivative rules. Because if you plug in 0 here, you get cosine of pi over 3 minus cosine of pi over 3 over 0, which is 0 over 0. That's indeterminate. Let's use L'Hopital's rule. And if we do that, folks, if we do that, you get that. Now, by the way, when I'm taking the derivative here, I'm taking the derivative with respect to h. And I know I'm doing that because that's the only variable here. All right. And yeah, that's what I would do here. And notice now if I plug in 0, I just get negative sine of pi over 3, which is what they wanted in the first place. And I did a derivative to get there. It's pretty friggin' slick. This is like my favorite application of the L'Hopital's rule because while conceptually, yeah, you should know all the different things and you should know all those other pieces, you don't have to. You can just be like, nope, L'Hopital's rule. There we go. All right. Your turn. I'm going to give you 5 minutes. I want you to try to work in these 6 the best you can. Again, try them on your own paper. And then after that 5 minutes, I'll share answers so we can check and talk about whatever ones you'd like to talk about. All right. 5 minutes. Work on them in your own papers. Go. Oh, there's the time. All right, I'll stop this. I think I know what I want to do. All right. So now that you've tried some things, here are my answers. So as you're looking at them, here's what I want to talk about is which ones would you like to talk about? Why don't you share in the chat which letters you'd like me to look at? Fabulous. Thank you, folks, for giving me some responses. B on the bottom and E. Sick. All right, let's do those. Oh, just a moment. Sorry about that. Okay. So let's do B on the bottom, and then we'll do E. There it is. Okay. So if I go to infinity, I see X on the top and the bottom. So this is going to go to infinity as well. So if I was going to do this one, I can do it with L'Hopital's rule, or I could do it with dominant terms. Dominant terms is probably what I'd pick for this one to make it more efficient. But I'll do it with L'Hopital's rule just to point it out. So if I did this with L'Hopital's rule, to start, I would get 20x to the third minus 12 over, I'm going to rearrange the bottom. 60 x to the third minus 9x squared plus 18. Now, I think the more you do it, the more you can quickly see that like this 12 is going to go away. The next derivative of this, and let's change colors for the next derivative. The next derivative of the top is 60x squared. The bottom becomes what, 180 x to the second minus 18x. I can do the derivative probably once, twice, 2 more times. So I'm going to jump to that. If I do it 2 more times, red will probably show it better. If I do the derivative 2 more times to the top, I'm going to get 120. If I do the derivative 2 more times down here, I'm going to get over 360. $120 over 360 simplifies to 1/3. So that's how I do that one with L'Hopital's rule. Yeah, it is cool how it works. This one, Again, if I was using all of my different techniques, I would try doing dominant terms. I would just grab these two and then simplify them, and I would just get 1/3. But again, I can only do that because it's going towards infinity. But L'Hopital's rule still gets me there. In fact, it's really not that bad. And L'Hopital's rule at some levels kind of employing dominant terms to make it quick and efficient. But whatever. There it is. E. Let's look at E up top. And I'm going to do that one in pink. So if you plug in 1 for E, I just keep losing where my mouse is. I'm going to get 0/0, which is indeterminate. Let's use L'Hopital's rule. Well, the numerator becomes 1. The denominator becomes -1 over x squared. So if you plug in +1 to that, you just get 1 over -1, which is -1. So there it is. Any others you want me to do? You had about a minute. Correct. It only comes into play when it's indeterminate. So if I had something else, that if it's not indeterminate, then I would have to try a different technique. But if it's not indeterminate, you probably either A, have the value of the limit, or the limit doesn't exist. It's undefined there. So usually you can make this work. Not always, but usually L'Hopital's rule will work for you on pretty much any limit that you can't get just by plugging in a number. All right, I'm going to clear the drawings. Yeah, L'Hopital's rule, it's a slick rule. It's pretty awesome. It can make things, it can oversimplify a lot of problems. The hardest part about L'Hopital's rule is that once you learn it, remembering not to confuse it with the quotient rule. All right? Because this one, you literally just take the derivative of the top, derivative of the bottom, and you leave them separate. Whereas with the quotient rule, there's a lot of combining and things that happen. But that's it. So here's your practice. It's due soon. Again, I keep saying due soon because I just want you to work on trying to get it done. That's the big thing. To give you a little more of a hard deadline on just some stuff, I would recommend that you try to have the best day. Try to have 3-1 through 3-4 almost completely done by the Monday, by the 30th, which is the day we get back from break. So I would highly recommend that you try to get that done by then. All 4 of those done by then, because we're going to start on 3-6, which is kind of a review of a lot of that. So that'd be super helpful. Yeah. Also, check out the post credits. There's some extra examples in there that'll help you with like one problem from the practice, which is why I'm not spending time on it, because it's one problem. So go check that out. Again, here's my awesome Kung Fu Panda meme, and I'll just love it. Just love it. It's my favorite. That's all I have for you. Have a wonderful day, folks. Hope to chat with you later. Peace.